In this segment, we'll look at set operations on subqueries. SQL includes several operations treating query results as sets and allowing union, intersection, and set difference computations on query results. Any pair of queries having the same column count and ideally the same column types and names, though this isn't actually required, any such query may be combined, or pair of queries may be combined via a set operator. And here's an example on the Bakery4 database. So select ID first name, last name from customer and meeting certain age criteria, and then a union set operator and another select. Now this one's pretty simple, and as we'll discuss can be easily done without set operations, but it illustrates the pattern. Pairs of subqueries may be joined by operator union, with the result being a set union of the rows from both subqueries. The parentheses surrounding the subqueries are mandatory, and the resultant union removes any duplicates, even if there were duplicates in either of the two operand subqueries. You can see this by running each subquery in turn, if you like, and then running them combined, as we did here in the union expression. The result is all rows from either subquery, but with customers Stens and Haferkamp repeated only once, despite the fact that they do appear in both queries. You can add the usual modifying phrases, for instance, order by or group by and so forth, to the result of a subquery set operation. Let's order the output of our sample query by ID. I'm just going to add an order by ID there. You can see the result now is ordered by ID. The order by operation that we added has lower precedence than union, so the union is done first and the order by automatically applies to the result of the union with no additional parentheses needed. The union is also usable as a subquery in all the usual ways, including as an inner view, a list, and so forth. Here, for instance, is a query that uses our example union as an inner view, computing receipt averages for each customer in the result of the union. The union query is set apart so you can see it, and it's renamed as chosen per the usual renaming requirement for inner views. And there's the result. Now, as mentioned earlier, the union example that we've discussed so far can be done just as well by other means. So write a simpler query that has the same outcome as our sample union, repeated as it is in the notes. And an answer you might come up with is select distinct ID first name last name from customer with the condition that age be greater than 18 and state in California, or alternatively that age be less than 50. This just gets all the customers who fit either the first subquery or fit the second. In general, a union of selects on the same table can be done more elegantly with a single query having a where clause that is an or of the two where clauses in the selects. But this is not so when the two queries differ more radically, drawing perhaps from different tables, though producing the same column number and type, or from the same tables but with one query grouping or aggregating rows differently from the other. For instance, write a union query on courses 3 that returns first name and last name for all people who might be interested in difficult courses. And let's assume these are students whose GPA is 90% or more of the max GPA among all students, thus strong students, and teachers who teach at least one class where the class average grade is equal to the lowest of all classes, thus hard case teachers. And note, by the way, that a three-way join between person, student, and teacher won't work, since this would only return people who are both a student and a teacher, while we will accept people who are just one or the other as long as they meet the respective criteria. Now, it probably took a good bit of effort, but here is at least one reasonable solution. The first subquery gets first and last for the high GPA students, and the second gets first and last for the teachers who teach low GPA courses. that two subqueries produce compatible sets of columns, but they work on different tables and they each use different joins and they use different subqueries in their respective where clauses. It would be impossible to combine them in a single query without a union operation. As a good example of the usefulness of union, recall the way we filled in the department table when converting from Courses 1 to Courses 2 in an earlier lecture on altering databases. We created a department table, and I'll kind of bring the notes in here, thus, and then when we needed to fill it with department string names that appeared in several database tables, removing any duplicates. We created a temporary department names table and inserted into it all department string names and then shoveled all the distinct names from department names into department. Here's the SQL we used. Recall that. So question 3, write a single insert into select without using department names that fills department correctly from the 3 other tables without duplicates. You may need to make a few obvious assumptions about multiple union operations. So a reasonable answer then would be, pump it up here, insert in department name, and then a select department from teacher, union select department from section, union select major from student. You can chain several subqueries with union, as would be the case for any typical binary operator. And at the risk of being repetitious, you get the duplicate removal for free, since union produces sets. So there are clear examples where union makes possible what could not otherwise be done in a single query or without use of temporary tables. Generally, these cases involve combining results from various tables or from different join structures. SQL offers other set operators in addition to union. Operator intersect performs a set intersection on two subqueries, returning only rows present in both. And operator except performs a set difference, removing from the results of the first subquery any rows in the second subquery. But MySQL offers neither of these two other operators, and it's informative to explore why. They're in the SQL standard, but they're not supported by MySQL. Here, for instance, in the notes is a simple query, which is not runnable under MySQL. It finds all purchase dates on receipts that are not also start dates of discounts. Now, in SQL, you could run select purchase date from receipt minus or except, either one will work, and then select start date from discount. So question 4 is, rewrite this into an equivalent query that is runnable under MySQL using a not in operator and no joins. And the solution for this would be, as an alternative to select purchase date from receipt minus select start date from sale, we write select distinct purchase date from receipt or purchase date not in select start date from discount. And this gets purchase date from receipt, but only if they're not in the list of start dates from discount. And it uses distinct to remove duplicates. So it's doing exactly the same thing as except or minus, its synonym. The approach will work with any except expression. Just convert the query 1 except query 2 into query 1 with distinct, where result columns not in query 2. And of course, a similar approach works for intersect. What small change would you make to the answer 4 we just discussed to make it implement intersect instead of except? And the answer is just replace not in with in, and you'll get intersection behavior. So set, intersection, and difference are readily implementable by tests against list subqueries, which is why MySQL omits the intersect and except and minus operators from its syntax. Interestingly, though, this is not true for union. A where clause testing against a list subquery inherently filters or restricts the results. It can reduce what the main select returns, but it cannot augment it. So for set union, especially across disparate tables, we need the union operator.